Recording, share the screen. All right, so we are sharing. So let's go to Brightspace here. Content. So I should once again. All right, so we are back, I think. Once again, I'm going to point out where all the links are for this, right? All the documentation is here. So go to KNN mini project. All right, I will be adding the link to this now that this is due a week from Thursday. Okay. So if you click on this links here, it'll take you to all the links, right? How to set up GitHub, and so that you can do your website from there and run your application. As I said, you can run the you can choose to do this or not. It's not required. This is more like practice. This is deploying KNN on the web, and this is the actual generative app. Okay, so this is the actual generative app. So this is what I'm going to go over today. Just kind of illustrate what everything is, so you guys can do the work. And like I said, the only thing is you still need to get the images. And I do recommend that the images be the same size. Okay, so this is literally, yes, sir. No, it's not deep learning. It requires tons of data, but obviously the more images you give it, the richer it's going to be, possibly, right? I don't know. It's entirely.
We're looking at like 200, 500, like what?
Between 100 and 1,000, yeah. More than 1,000 might be it may not be unreasonable if you download a data set. I mean, the data set may exist already, right? So it's not a thing. You don't have to label much. Right? It just depends on how you are at selecting what's your problem.
Like each pixel being its own feature.
Yeah, I mean, exactly. To generate the new image, you average out on a pixel basis. Yes. So if you have images that are 28 by 28, the output image is going to be 28 by 20.
I'm sorry, I guess for the training, for
the feature vector, you mean?
Feature vector.
Yeah. Yeah, it's KNN. So yes, well, it's not. So here again, I'll repeat that the KNN part is not happening on the images. It's happening on the other feature space, right? That's where the distribution of the points is happening. And that's what you use to select which images are closest. So we did an example of cars, didn't we? Like I had an example of some cars, and we had like some cars that had electric and others were like high performance cars. We had images of that, but KNN was not happening on the images of the cars. It was happening on the associated vector. So each image will have an associated vector. And I think we did something like weight, horsepower, something else, right? And we had 3 features. So the KNN happened on that space. You can think of it as there being 2 vector spaces. One of the images, 28 by 28, and another one of, for each image, you have an associated feature vector, but that's the condition. And that's where the KNN happens. Okay. So let's build this up today. How about that? Let's go over, try to build the application, and see if you guys understand. I assume you guys have done this part, okay, which is creating your own repo on GitHub and deploy pages. So you've created like your own index hello world website, okay? So I'm going to click on this one. And then I'm going to click on just kind of go here. Everything that you need is in this example 3. Everything, like the whole thing that you're doing is here, okay? So if you notice, there are 3 files in here. This is the data. Then there's only one index file. That's it. That's your whole app right there. Okay, that's going to use PyScript that has the KNN algorithm, everything. And then I added this Jupyter here just so that I show you an example of how to go from images to some CSV files. So basically think of it as I have a folder of images, it goes into this, and then I get these 3 CSVs. Got it? All right. So I'm going to go over this today. First, I'm going to describe index.html because I think that's really where you guys are probably like a little bit like don't know. And then after that, we're going to get to the Jupyter and discuss that as well. Does that make sense? All right. So for this, I'm going to be building this, right? I'm going to build this up. So I'm going to go here. And I'm going to go to ML Foundations, which is the course. So this is our course. And I'm going to go to Deploy to Web. TensorJS here. Yeah, I have an index page here. Yeah, so let's just deployment here. All right, so we'll create it if need be. All right, so let's go to deploy to web. I'm gonna keep it here. This is where it makes sense to have this. All right, so you need to create, basically, this is kind of what you guys would do, okay? Create a folder, and in this folder is where you're gonna deploy your application. I'm literally what I have in the other folder, I'm gonna start copying here slowly and describe it. This is what you guys have to do, okay? So it's pretty straightforward. You can actually code right here, right? So that's what I'm going to do. Okay, so I'm going to I'm already logged into my GitHub. I'm going to create I'm going to show you like the tricks that you can use. So I'm going to create in deploy to web this. I'm going to call this KNN generative KNN. How about that? So generative KNN. See that? That's your project right there. I usually add a README whenever I do this. So readme.md, and I'm just going to say generative KNN. You see that? That's basically it. So you can hit commit. Oops, sorry. Commit changes. Yeah.
Very simple question. Actually, possible.
Okay, great. All right, so I just created basically on GitHub the repo. That's that first link. All of this is that first link. It shows you to create your own repo and everything. Pages is something else that you need to enable Pages on GitHub for a website to run. Okay, otherwise it's not going to run by default. Like a normal HTML, CSS, JavaScript will need to run with Pages enabled. So we'll get to that in a second. So my project is going to live in generative KNN. So it's really, I'm just copying what I have in here. So I need an index.html file. That's where the project, that's the website really. And a lot of the projects that we're going to deploy, whether it's Onyx, as we start moving into neural networks, we're going to do this again, but with another thing called Onyx. And so same idea, you will always deploy an index HTML, more JavaScript possibly. Yes.
What's Onyx?
Onyx is just the open Microsoft framework for deploying machine learning models. It works on TensorFlow, PyTorch, so it's open source. Okay, so we will need that when we move to like the neural networks. All right, so now I'm going to create this file, index.html. Okay, so I'm going to go ahead over here. I'm going to hit create new file. Index.html. You see, oops, sorry. Nope. So lowercase index.html. You see that? Pretty easy. That's it. Give it, of course, this is now an HTML file. So what is it? HTML, right? And then a head section, you know, what you learn in 110, right? So head, and then body. You see that? That's it. So all of our machine learning models that we're going to deploy are going to follow this basic approach. We would use JavaScript for later. For now, we're going to use PyScript, okay, which is this way that we can run actual Python code from scratch on a normal website. When you save, what you do is you hit commit, and then you hit commit changes, and basically that's it, okay? Got it? All right, now what I'm going to do now is I'm just literally going to copy the code from the other one on here. All right, so let's go ahead and do that. So you can see this is the reference project code that I provided. So backup is just, as the name implies, it's just a backup file. Really, your whole project would be this file and these 3 CSVs or 2 CSVs, depending on what you decide you want to do. So I'm going to open this one, and you can see it's really just standard HTML, right? That's it. That's the whole project right there. So it's not that much. So I'm going to go ahead and copy the sections here and then just kind of describe them for you. Okay. So we are recording, aren't we? Yeah. All right. So let's start with the head section, you know, just because of the relevant things. I'm going to copy that. Go over here, click on an index. I'm going to hit the pencil. And so I'm just going to add in here contents of the head section. Yeah, please. Zoom in. Not sure how to do. Oh, there we go. How about that? Yeah, great. So basically, what do we have here? We have a title. So this is going to be your generative KNN, right? And just, you know, as an example, gen shoes or something, right? So you're going to imagine, which we're not that far away from this idea, actually, some factory somewhere in the world that you just give it the design and they make you a pair of shoes or sneakers or something like that. We're not that far off from it. So then you create a tool. This is when they say like AI is going to take all our jobs and everything. That's kind of what this is. You have a factory somewhere, and instead of hiring a whole bunch of great designers, right, to make things, you just create a tool such as this, and you say, here's a dress shoe, here's a basketball-related shoe. Generate something that the world has never seen. You do it, and you're like, hey, I kind of like this thing. And you send it to that factory. It's for sale. That's it. You know, it AI generated, right? So this is just a very poor man's version of that, right? Not a very complex one, but still, we can generate an image that has never existed before, or in fact, a design that has never existed before, just by averaging. That's all we're doing, but in a smart way, right? You have parameters. All right, so as I said, I'm just using this example, Gen Shoe. So there's the title, you know, character set is UTF-8. You know, you can add a little icon there to your nav bar. Now notice these things are important and you just use the same things. So you're gonna use the style sheet from PyScript.css. Remember, we are using PyScript. This is a new project out of Anaconda that initiated there, I believe, belongs to them. It's open source. They're working in Rust, the last time I heard, to make this faster, okay? So maybe it'll be a good thing in the future, okay? So it uses PyScript here for the CSS, and then we have, as you probably guys, if you took 362 or something like that, you remember jQuery, all of that. So you have here, you import the JS, which is PyScript, PyScript.js. Okay, and then you have another style sheet if need be. Okay, that's it. Does that make sense? So this is like the libraries that make PyScript work. Any questions about that? All right, great. So we did that. That's it. All right. You can hit commit if you would like. That's fine. Okay. We do have a website at this point, so it might be a good idea. Although this is already in the links that I provided, I can show you pages and how that works. It's incredibly straightforward. Go ahead and click on settings here. If you scroll down here, you see this link that says pages. Click on that. Oh, I already did it. So you can see mine is already a website because it says it's live. If you haven't done it yet, you would click on this and there would be something like this, I think. Then you click on this one and you select main, okay? You select main. Once you've selected main, you hit on this save button that I already hit. Give it about 10 minutes. Boom. Pages is enabled. You can run your own static websites from your GitHub. Okay, we will come back. We will continue to use this throughout the semester. Your final project at the end of the semester will also be like this, but just with Onyx instead of this. Got it? All right, seems like this is very clear to everyone. So let's go ahead and return to where we were. So hopefully this website will run. What I like to do with these things is because the path gets long, right? The path gets long. You have to know what the path is going to be. Is I just add it in the README and then I just click on it and I get to it. All right, so that's what I'm going to do here. So if you click on the README, you can say like, link or something, right? So this is going to be my link for this site. And then whenever I click on it, I get to my site. That's it. All right, I don't remember what it is actually, so let me just hit on commit. And I need to get it from, this is going to be specific to you. So we're going to need, it's going to be this path for sure, but we need I think I need to get that from here. Go to pages, so it should be this, okay? So I'm going to copy that. So this is like the URL that you need. Okay, so now let's go ahead, go back to the README page. There we go. So now we're going to add that. Okay, so you're going to get an HTTPS. So it's got security taken care of by Microsoft, right? So we're good there in security. Definitely recommend this over other places that are really insecure. So you have your user. This will be whatever your user was when you created this, github.io, and then basically the name of the repo and the specific path to where it is, ending with index.html. So I believe it would be these, correct? So let's go ahead and click those, copy, Control-V. So after machine learning foundations, I have this deploy to web, then my generative KNN project, and then finally index.html. You guys see that? That's it. That's your project. That's all it took for you to have a deployed AI project on the web that everyone can access. Not sure where that is. Okay. Get rid of that. Changes to the READMEs are usually instant, but changes to the web are not. So it usually, for whatever reason, takes about 10 minutes for anything that I do to be updated. So don't get impatient if you make a change and it's not reflecting. Always give it about 10 minutes. I don't know. For some people, it might be less. Other people might be more. So if you click on this now, no, it's actually working. So you see, I clicked on it, and it's loading this Pyodide and everything, Python startup. This is what I was saying, that they're working on it with Rust, making it a little bit more efficient, or whatever tools they're using. So definitely, hopefully I'm excited about PyScript, that it'll become, Python on the browser. What else do you want, right? All right, so anyway, you can see the page here is blank, but at least you've completed deploying your app, right? So anyone in the world can play with this now. So now let's go ahead and continue the development. So we're going to go back to the index.html file and take a look at the other parts that we need to have in here. And then after that, you'll see that we're going to need the files. And then we're going to jump to the Jupyter to go from files, image files, to the input to this tool, okay? And then hopefully things are going to start clicking in your head. And please stop me if you guys have any questions about anything, let me know, okay? All right, so I'm going to click on the pencil here. All right, I'm going to go back to my reference, which is the link that I provided. Notice that was all for the head section. Now we've got the body section. You can use all your creativity here. I actually think maybe scroll bars would be kind of fun to but I just did this with text boxes. So there's a nav bar and this table. So I'm just going to copy that first. That's just like pure HTML things. There's also a button, yeah, here. So I'll just copy this part. All right, so let's go back here. We're in it. So now we go to the body section. Control V, right? So what did I just do there? I basically, this is the start of body. So this section here is really just that nav bar. It's not really for anything else and for it to look kind of nice. It's got a logo, some things, right? And it's got a name here, KNN average generator. That's actually an appropriate name for this. It is a generator, a generative model that just averages images based on conditions. Got it? All right, so that's pretty clear. Then type condition here. Now this table is really where I have those text boxes, okay? So this you can change to scroll bars, yes.
They're pretty much the features, right?
There's the features, yes. Remember, they are here. The images is what we're averaging, but remember that actually the KNN space is not related to the images. It's related to the characteristics that describe those images, whatever they are. So refer, yeah, Henry.
We're gonna have to label 1,000 images ourselves.
Think about it. I mean, solve this, use your powerful brains to solve that problem efficiently. It's a very common problem in data science. So you got to figure it out. Be smart about it. There are tricks that you can either find data sets that already have this or find things with associated. Yeah.
We use AI to generate our data.
Maybe. Yeah, maybe.
Underline labels the features.
Yeah, maybe. You could say, ChatGPT, here's an image. Give me some characteristics of it. You know what I mean? I mean, you could do things like that. I leave it to you to create this data set and your creativity, okay? But I'm just showing you what it would look like in the end. Does that make sense so far? So I'm giving you a table here. If you notice, this is just a table of 3 rows, I think, or 2 rows, maybe. Yeah, 2 rows. So each one of these, you can see you've got, it's basically TRs and then table data elements. Inside them, you do have inputs, right? And you guys remember these. These are the text boxes, okay? Notice I did provide some default values, and that's just because what you're going to be testing this a lot. You don't want to type a whole bunch of things, present, and instead put some default values in there. Okay, you can use this as reference, basically. So here, this is this is actually something easy to understand. Is the project was the furnaces, blast furnaces at Gary work. So chemical inputs, natural gas, oxygen, coal, iron ore, all that goes in. What does the furnace look like? Is it hotter? Is it colder? Right? So in your case, think about this problem. How could you use this to generate something else? Okay. All right. So I added this. This is pure HTML. And then down here, if you notice, I just added a button. Remember that you need to have IDs, etc., so that you can reference things. Like when you click a button, things need to have IDs. Notice that when you press the button, you do have something new here that you may not have seen before, something called PyClick. And PyClick is, whenever you see Py, it means Python. So it's telling HTML to go look in the PyScript section for the function myGen function. So myGen function is what is going to call everything else, all the KNN things and so on. All right, this is a Py button. And then basically the button just says generate. Okay, so this is what triggers everything, basically. And then these are just divs and a paragraph tag, but they do have IDs, which is really important, such as test output, pandas output, current val. You can use these for debugging. So there's going to be a trick where you generate something in Python, and then you have an output. Now you need to send it to a tag. So you're going to need to send it based on the name of the ID. Okay. All right. So that's it. So basically, if we click on this one, commit. Okay. So I would give this about 10 minutes to update, and then the website should be complete. So now I'm going to hit on the pencil again, and I'm just going to add the next part. So the divs is what I added last. So now I'm going to go in. And if you notice, this part here is where the PyScript code actually begins. Okay, so I'll kind of leave that for last. But let's just finish it at the bottom to make sure we haven't missed anything. So HTML body, section, and script. Section and script. So I think, yeah, so I think all that's left is basically our PyScript section. Okay, so I'm going to add here, have this PyConfig, I have this script. So I'm going to start with this, control copy. And this should be, yeah. So then here, this is now what is new to you. No, oops, sorry. Notice you create a section and it's a PyScript section, okay? This is just some div. If you notice, it's open and close in there for reference. Maybe if I reference something as MPL, I'm going to write to it, okay? So that's kind of, you can play with this. But this is the start of the PyScript section, so we need to close it, right? So that means we should go down here and grab our closing section. All right, there you go. Now, the two sections that are left are actually like the imports in Python and then the actual code in Python, right? So I'm going to go here and do just that. All right, so I'm going to grab this one, PyConfig, going to copy it. And now this should start looking, for you guys that love Python, right? This should start looking familiar to you now. Notice you got your PyConfig and what's in there. Packages, matplotlib, pandas, right? And then you have some plugins like something from PyScript that you may need or not, okay? Remember that at the end of the day, we're going to generate, if our images are 32 by 32, we're going to generate a NumPy array that is 32 by 32 with your data. The trick is going to be, you need to take that and convert it back into an image. You see that? So that you may use your own creativity, or you can just use the strategy that I'm showing you here, okay? Any questions on this part, PyConfig? Pretty easy, right? All right, so believe it or not, that's almost it. And now comes Python code, which is exactly like the Python code we were doing before, except for the trick of reading from HTML and sending back the HTML. All right, so now I'm going to go over here. Oops. And this is the, notice I start with script type py, right? So I'm going to go ahead and copy this. And I'm just going to copy the whole thing. All right, and it ends there in script. Do you see that? So I'm just going to copy this. Okay, go in here, and I'm just going to paste it in this section here, basically, like that. See that? And it's starting to look like Python code at this time. So that's kind of what I'm going to start describing. But as you can see, it's pretty straightforward. At this point, I'm going to commit so that, you know, the changes start to take effect on the website. What did I do? Did I not hit commit? Okay. It's like slow. All right, we can just fix it if. Are you guys having issues with your internet? So. Okay. Let's just give it a minute, see if it works. May just hit cancel. I don't know. All right, I'll try it again. So I'm going to go back to generative index. Seems to have copied it. So I think it's there. All right. All right. So we're going to review it. All right. So that's the code, right? So if you guys were doing your project, that's it. You may need to change it a little bit. And of course, you need to have those CSVs be specific to your problem. But this is it. Okay, so that's why I was saying it's straightforward. So now let's go again, and let's start like discussing the actual Python code in here. All right, so it starts here, right, at script type py. This is where it's actually now just pure Python. So if you look over here, these are just standard Python libraries, matplotlib. I'm using that actually to convert the NumPy arrays into the visual images as a figure. But there are other tools that you might want to try. So I leave it to you guys to try that. NumPy works perfectly fine, and we use it here. Pandas works nicely. You do need this thing called Pyodide, or you can use this Pyodide that's from PyScript. It's going to help you out. JS, and several other things. So all of these libraries work, right? So we have them available. Then if you notice here, I have this section. What does that section do? It basically grabs the data that I have on the repo, and it's going to download it. So it's called URL. It's got the full path, and it's the CSV file. So this is how you can load your data. Okay, you basically just throw it in there in the repo and then access it through the URL option. The only problem may be that, remember that GitHub limits you to 25 megabytes. So the files, anything bigger than that, you're going to have to break it up into multiple files, read it from those, and build it together. Okay, that's the only downside. So I'll come back to these in a while, but basically we read one and notice we're going to read the file through pandas and convert it into a NumPy array. You guys see that part? All right, then another file here, same thing. We're going to read it with pandas, convert it into a NumPy array. And finally, the third file, also read it with pandas, convert it into a NumPy array. So imagine at this point you have 3 NumPy arrays in there somewhere, and that's what you're going to use for your data. Remember, KNN is a lazy machine learning algorithm. What that means is there's no training, right? Which is going to be very different from what we're about to begin next week with neural networks, where you do have training and this whole set of ideas. But here you're just using the vector space model. All right, so you have your 3 data sets in NumPy arrays. As I said, we'll come back to that. Now, what's this? You already know what that is, right? We spent a lot of time talking about the Euclidean distance function. Is the exact same one that I discussed. You need it to measure the distance between a point and other points, right? And then here you use KNN. You see, you have a function called predict right there. Same idea. There's another function in here called get NP conditions. What is that? That is the function that just gets the values from the text boxes. So whatever you input as the conditions in the text boxes of what you want gets grabbed here. You guys see that? All right, so I'll come back to it. I'm just kind of doing a high overview right now. So basically 2 functions, or 3. The Euclidean distance, the KNN algorithm, exactly as you know it. The get conditions, which just gets the values from text boxes. You could change this to be scroll bars or something like that. And then you have the function, mygen function, which remember, this is when you click the button, you come here and you execute this code, okay? So that function is going to be all the way, it's kind of a long one until here. And that's it. That's it. That's the whole project. Those 4 functions, okay? So now we're just going to dissect into the different functions, right? And then hopefully the question will start to arise of the data set itself. And then we're going to go to the Jupyter. The Jupyter you can run like in your local machine, generate the CSVs, and then deploy what you. This is going to be the normal pipeline with PyTorch. You run, you train on GPUs, whatever, and then the model gets saved as a file, a serialized file that you can later on use. So we'll see that in the future. All right, so now let's start. The whole thing starts here, right? You press the button, you come here to this function, myGet function. So what's the first thing is you need to figure out. So remember, it's KNN. That means you have a vector space model of examples in there, right? Like this room in 3D, all of you are points in this space, right? That's in one of the CSVs. In the text box, you're going to say, I want a student who's wearing brown jackets, no hats, and kind of dark blue shoes. That's these 2 guys right there, right? Do you see that? So those conditions are the axes of this space that bring me to Cody, Brock, and Mark, right? So brings me to them, and then basically I just know those 2 points, but I want to generate a student. So I'm going to take the 2 of them and average them, or the 5 of you and average. And that's the generated image. You see what I'm saying? Now I don't average based on brown shoes and brown jackets and blue shoes. I just find you guys based on that. Once I find you, instead of grabbing a class, what do I grab? The file name of the image that's associated with you and the image that's associated with you. And that's what I average. Do you see that? That's it. That's the thing you need to understand. Are there any questions about that idea? All right. So this vector, getNP conditions vector, gets those values from the text boxes or the scroll bars or whatever it is. Okay. So let's take a look at how that works. And then notice it generates test X, which is some kind of a vector, right? It's some kind of a vector here. So I'm going to go to get NP conditions, which is this function. Okay, this function should be, let me get my charger. All right, so get NP conditions. How does it work? In PyScript, we have this object called element. This allows you from PyScript code, which is like the Python part, to get things from the HTML file. So this might remind you of get element by ID in pure HTML. This is the equivalent of that in the Python section here in PyScript. So you do test input 1. Remember, this is the ID of the text boxes. So test input 1, 2, 3, pretty straightforward. You grab it with element right there. And then you grab element, and then you grab the value itself, and boom, you've got the number. Right? And then this is just converting it to float, basically. It's typecasting. So I have 10 text boxes in there. So I created 10 values, okay? 10 variables, basically, okay? Once I have those 10 variables, notice all I'm doing is creating a list, and it's called conditions list. This is the features. This is the vector space that you need to define. For my case, this was like natural gas, amount of coal, amount of whatever heat, right? But you guys need to define this and associate the vector to your images, okay? This is just straight up Python. So after converting this into a list, I run this list through NP array. We know what that means. It just converts it into NumPy. That's it. So now I call it NP conditions. And then notice here, I'm just doing an expansion of dimensions, right? So this is probably to be 1, 10 instead of 10. Do you see that? So I'm making it into a row vector. Okay? Once I do that, I basically return whatever is in those text boxes as a NumPy vector that I'm going to use. Okay. So what is this? This is the thing, the test sample. And then what do? I'm going to compare this to all the samples in my space, right? Calculate the distances, sort it, select the 5 closest. Once I have the 5 closest, those 5, I get the image that corresponds to them. Let's say 5 images, average them, generate my new image that has never existed before. Do you guys see that? That's the whole process. All right, so that function is complete. We can see here this returns a vector of size 10, right? 10 features. Any questions? Okay, so I have test X, vector of size 10. Okay. All right, now here I have, this is just me printing out certain things. Okay, so you can see here, I have an element called test output. So what is PD? Oh, these are global variables, aren't they? Yeah, so these are the files that are global variables. So you have here PD IDs train NP, PD conditions train NP, and PD images NP train NP. All right. So those are 3 global NumPy arrays, basically. And so this part is just kind of like for printing purposes. Like I always do in the Jupyters, just print out shapes and things like that. So I'm printing the shape of this one. That's text 1. So this is just for like, this is NumPy, then I convert it to string, then I save it into this variable. Take the shape of this one, same. Shape of this one, same. Shape of test X, same. Then I have text 1, text 2, text 3, text 4. I concatenate them as text, and then I added to the inner HTML of test output, basically. Do you guys see that? To look at the shapes. Any questions so far? All right, so let's try this. So I think it's, I haven't made any changes, right? So I don't have those. Well, actually, I have the full path of those files, don't I? Yeah, so this will work. Okay, so let's go to generative KNN. This is the one we're building. It's doing that. You can see now it's got the text boxes. Give it a minute. Okay, right. So there you go. The app runs, then click generate. These are the shapes. You guys see that? No? So these are the shapes that I was describing previously. So these. So in particular, the conditions, test X, right? What is the shape of test X? If we go over here, 1 by 10. You see 1 row of 10 columns. Make sense? You have a question?
Are you doing a classification problem right now? Like basically like trying to find out like based off of whatever the.
This sample 110 is the test sample. And this is going to be compared to all the other data that you have in that vector space.
You're trying to label you're trying to label that's most common of the 5.
You're going to find the 5 closest samples to this one via KNN. Once you have found those 5, what do? Instead of the class, grab the image that's associated with that. And you're going to grab, in fact, the 5 images that are associated with those 5 closest samples, and then average them to generate the new image. That's it. That's the whole project.
Probably another question by averaging.
Averaging. So averaging is like, you know, like, don't have my tablet, but not gonna do it. All right. So averaging, I just mean like you have, let's say, an image that is 4, and let's say this is another image that is 4, and this is 2 and 2, and this is 5 and 5, and this is 6 and 6, and this is 3 and 6. So averaging these images to get a new one means what? What is 2 plus 2 divided by 2, right?
Wait, I'm sorry. Yeah, I know. I'm sorry. I know what averaging means. I guess what number are those numbers?
From the images.
Image itself.
The image
Or-
itself.
Like the pixel or like.
Yeah, the pixel. These are the pixel values. Yes, exactly. Is that your question? You're averaging the pixel values in an image. Okay. All right, so let's keep going. Okay, so this is of size 110. The other ones, as you can see, I have 660. To answer your question, I had 667 images in here. That's this. 667 images. Now notice I have 2 like files, right? One file is 667 by 10 because that is the space of the conditions, right? And the other space is 667 by 5,464. Why 5,464? That is the size of the images. So if the images were 28 by 28, this would be 784. Do you understand? So I'm storing the images literally as in a CSV. Every row is an image. So I have ID 3 with its corresponding image, let's say a vector of 784. But I also have another file where ID 3 is a vector of 10. And those are the 10 characteristics that describe that image. So effectively, the KNN is not happening on the image space, but on the conditions space. Okay, got it? Yeah, go ahead, Barak. Yeah, this is just another one I have with the IDs. We'll look at the files in a second, but yeah, it's 667 by 1 is probably the ID. Or it's probably, it's not the IDs actually, it's like the conditions and the file name. You'll see it's like, it's just a string file. I'll show that in a second. All right. So again, these are your files. If you have 667 samples, you have one for the conditions and one for the images. Where I just, remember the last two problems in the NumPy's homework, right? I just flattened the images. Remember that problem where I asked you, flatten the images if they're 2D or 3D? That's it. These are flattened images. But they all need to have the same dimension. This is, for this to work, they all need to be, if they're 28 by 28, all images need to be 28 by 28. That's a requirement. Otherwise, you can reshape them or whatever, but at the end, when you bring them here, they need to be like this. Any questions? All right, so that's it. We're getting close to the end at this point. So that's what this code is, right? So this whole thing is not really required, but I recommend you print it out just so that you know all the shapes and you're familiar. It'll be consistent with whatever it is that you did. So then we have our test X from the text boxes. That's this one. Notice that that test X goes into the predict function, and the predict function returns generated image. So now we're going to go to predict. It takes in a vector of size 10. That's this one over here. If you notice, predict is just that KNN algorithm that we discussed previously. That's it. Nothing changes here. Notice that the code is literally the same. I take test X, for X in PD conditions train. Do you see that NP? What is this? This is the equivalent of X train in the other example. Where is this data coming from? PD conditions train NP. It's this one. It's one of your files. One of the files that you have, I know you can't see it, but there are these CSV files. CSV, CSV, CSV. Got it? So you take that file. So now you just run KNN here. So for X in PD conditions, right? You grab every one of the train samples, and you take also the test X and you invoke the Euclidean distance, just like we discussed before. It's the exact same algorithm. So now if you have 667 samples, you're going to have in distances 667 distances, just like we did before. Notice that I only use k equal 3, but you can play with this parameter. That's entirely up to you. Then you take distances and you do NP-arg sort. Do you guys remember NP-arg sort? It basically returns the indices, right? Or sorry, it sorts, but sorts by index. Okay, it returns the indices. So once we have this sorted and we have the indices, we just grab the closest k, correct? Exactly what we did with KNN. That gives us the k neighbor indices. That's KNN. And what do you do here? For I in k neighbor indices. So now you're going to grab the closest indices, right? But now notice you're grabbing it from another file, the file that contains the corresponding image for that index. And that's going to be PD, IMGs, NP train. Okay, so that's this one. That's the other file that you read that has the image data. Got it? Has the image data. Notice that at this point, I actually do this. What is that? Reshape. Why is that needed? Now, keep in mind, my problem here is only black and white. So I only have 2 grids. If you guys have color images, remember, you're going to have the R, G, and the B grids. So you'd have to do this 3 times. You have to figure out that math, but it's doable. Not difficult. All right, so I take an image, what was it, like 5,000 something, right? And now I just reshape it into a 2-dimensional one. Instead of a vector, instead of flattening, I do the opposite of it, right? I unflatten it, unspaghettify it, right? And now I have my image. Do you guys see that? So I'm doing this in a list comprehension. So effectively, if I selected 3 images, I am adding these 3 images to this list unspaghettified. So image 1, image 2, image 3. I have them in a list. And what do I do now? I take, that's this file here. It's a list of NumPy arrays. So notice that I convert the whole list into a NumPy array. And I'm going to specify the dimension I want to use. And I just take the mean. That's it. So now effectively, if you had, let's say, images 28 by 28, you had 3 of them. You average, you take the mean of them on a pixel basis, pixel wise, and it produces one final image that is 28 by 20. Or in this case, 140 by 39. That's it. That's it. You finished. And then here I'm just converting it to integer, play with that. And that's it. That's your returned image. Boom. Hard part is done. Right? Now keep in mind, this is still a NumPy array, right? It's still a NumPy array. So we need to visualize it now. We need to like display it graphically. So predict returns the image already averaged. Okay, so we are basically at this stage, aren't we? Okay, so now what do we want to do? What I did here is I wanted to see the values that I entered into the text boxes, because that's going to be changing, right? But I kind of wanted to record every image that I did. I wanted to see what the conditions were. And so that's what this is here. You don't have to do it if you don't want to. But notice it's basically I'm taking test X, right? That's the 10 values from the text boxes. And array to string, basically. And I set that they were comma separated. And then after that, I just started replacing things to create a string, basically. You see that? It's literally just displaying the values of the text box. And this part here, notice all of this is commented out. So I was actually trying some other things, but this is all commented out, so you can ignore it. So this part is the last part of this whole algorithm. And once I finish this, we are done with the app, and all that remains is the 3 files, of which we really just need 2, honestly. But okay. Are there any questions at this stage? Is this making sense? Any questions? Yeah, please, sir.
So this is black and white.
Yeah, so what I did is black and white. I know it looks color, but it's because I used a color map. It's a kind of like a trick where it's still grayscale, but you can say like, you give it like a little like, almost like a rainbow kind of thing. And so it can pick out the color. Yeah, it's a color map, but you guys can do this black and white. I leave it to your creativity, or do it in color. It's just a little bit harder. If you get color images, you can convert them to grayscale. It's not a problem.
I'll convert it back to RGB.
You can do that, Henry.
There'd be no point.
I leave it to your creativity to do whatever you want with this. I mean, my requirement is just, I want you to understand the vector space model, but I do think you can do some interesting things with this. And this is really powerful. It can be this is useful to someone, right? So knowing the temperatures of the furnace and things like that. So this is what I want. So anyway, I did this. This is like the easiest thing you can do. Okay, but there are other things you can try as well to generate better images. Just give me a second. But as you can see, all I'm doing here is using PLT. PLT is matplotlib. So I really just take the NumPy array, right? And I just give it to matplotlib to generate a figure. And then I send that figure to a div or something. Okay, so you can see that here. So you invoke plt.subplots, it creates a figure. PLT IamShow, right, is this here. I use a color bar, I use a title, like a label thing. And then this function should work. So if you do this. Oh, yeah. So I use this because I'm sending, well, this actually doesn't do anything. It's commented out. But anyway, so then the final part of this to display is basically to take figure 1, which has the generated image, and you're going to use this display function, which should be a PyScript function, and it sends it to target, which is MPL. What is MPL? MPL is some div in here somewhere. There it is. Make sense? So you basically send it to that div, and so whatever image you render goes there, and that's how it works. I thought we were going to take 2 lectures for this, but I'm going to be done with this today. Actually. So yeah, that's the whole code. That's your project, and all that remains is for us to discuss the files and the Jupyter. And we can do that before the end of class today. Got it? Any questions? Proceed. All right, so let's go ahead then. So as you can see, we've completed the whole process. Euclidean, the KNN algorithm. This just gets the inputs either from text boxes or a scroll bar. I print it to shapes. That's actually very handy. We predict, and then the predicted image just gets displayed with matplotlib. Yeah, Henry.
Good question. Could you express this, like, did you have the it isn't that different from the classification thing, right?
It's not that different. The only thing is, think of it this way. If it was a classification problem, you would have a lot of setosas, a lot of virginicas, and a lot of versicolors, right? For iris, we'd have 50 of each. But here, it's a file name for an image. So if there's 150, I have unique labels, if you will. Like I have 150 different labels as well, because those labels are really not labels. They are file image names. So I can look it up, retrieve those corresponding images, and average them.
Gotcha.
You understood now?
Yeah, my bad.
You see that?
I thought you were gonna have to, I thought it was like 2 CD files.
But you get it, right? So that's the beauty of machine learning, right? You can wait a minute, I don't always need classes. I can try other things and it'll still work. And this is a generative model. I mean, it's a poor man's generative.
And you could think of this as like a vector of labels, each little being a pixel, whatever.
Yeah, I understand that confusion that you're having. I think I have an example in a second that will clarify that. Okay, I think that's like the thing that's still.
I run the question in my own library.
It's two vector spaces basically. It's how you can think of it. Might be the best way to think about this. There's 2 vector spaces, but they're concatenated. Okay, but we'll get to that in a second. Okay, guys. So the code is done. Code is done. Over here. Oh, I'm here, I guess. So I'm gonna go back. You saw how quickly I got it to run. It works flawlessly. So now let's get to here. And our concentration is gonna be on these 3 files. So I think I only used 2, honestly. I was just like trying things out. But at the end of the day, notice that it's pretty straightforward. We use this open URL to be able to retrieve a file via URL. Then we read it into pandas via read CSV because it's technically a CSV. Then we take the pandas data frame and make it to NumPy. And then notice all I did is slicing. See how I told you that slicing was never going to go away? It never goes away, right? So it's one of the most important things. If you notice, what am I doing there? That should be very clear to everyone in this class at this point. I'm ignoring something, right? So I'm slicing from 1 to the end of rows and from 1 to the end of columns. That's it. And I'm doing that for most of these, pretty much. And then that's NumPy arrays right there. And I even showed you guys how to print the shapes over here, right? So that's basically this part. You printed out the shapes. Okay. So I assume the code makes sense. So now we're going to dig deep into the files themselves. So remember, this is where I'm building this app in the ML foundations, but I actually have this in where I provided the link. So I'm going to go there to show you that I don't want to copy the files and duplicate them. So I'm just going to go here, example 3, which is the link will bring you here. And notice the Jupyter is there, right? This is what I'll show for converting images to the CSVs. But we are ready to take a look at these CSVs, right? This is something that's going to be unique to all of you, okay? So let's just go in order. I'm going to start with, notice there's 3. PD images, PD IDs, PD conditions. Conditions is what I'm calling the thing that describes the images, which is something you have to define however you do it. Okay, so let's start with the easiest, the images. Notice it says it's view raw, because it's a little bit big. There it is. That's a lot of numbers, right? But if we look at it carefully, it'll make sense, actually. This from 0 goes all the way to like 5,000, which is right there, 5,499. If the images were 28 by 28, then this 549 would be 784, right? So this is whatever that, I can't remember, 139 times 67 or something, right? The dimensions of the images, when you flatten it or spaghettify it, give you this value. So this is effectively just the header of the whole file. That's why I ignore it. It's the header, basically. After that, if you notice, you have something more familiar. You have these values which go from 0 to 255. Do you see that? What are those? Pixel values. You see that? They end there. That's one image. Next image starts here. This is probably the index. So they have an index associated with them. I do recommend open this in like an Excel or something. It'll look better. But it's probably an index. And then if you notice the image again until there. Do you see that? So it's every image I have flattened it, and it's a row in this file. Questions? I think if it was a smaller file, we would see it nicely, but because it's big in raw, it doesn't look so nice. But if you guys want, we can download it in Excel later. It's not that big in Excel. This is just GitHub. Okay, got it? That's all that's in here. An ID and an image. An ID and an image. That's really important because the conditions also has an ID. So you guys remember SQL, right? You guys are pros in SQL. So think of that. You have the unique ID and then whatever the data is, and you would, what do you do then? You take that ID and match it to another ID that has other things. That's effectively what's happening here. Those IDs need to be matched, the image to the conditions. Okay. All right. So that's basically this file. So hopefully that makes sense. Then we're going to look at the next file. IDs trained. This one should open nicely. Yeah, so this one opens nice because it's not that big. This is just one way in which I wrote this file, but I think I ended up using the other file, actually. So if you notice, again, ID 5. Do you see that? That's an ID 5. And this is the conditions and the image name. But I actually didn't end up using that, but I think it's useful to think of it this way. This is just a string. So what is it? This means that if this is 5, this needs to correspond to another file where you have a 5 and the image data is there. You see that? So I do the KNN in this space, conditions space. Find the ID, find in fact the closest N IDs, 5, 10, 14, go to the other file, find those IDs, retrieve those images, they're all the same size, average. That's it. Any questions on this? Yes, please.
You mentioned word conditions. What do you mean by, like, what are the conditions?
It's the thing that describes the image. And you have to do that.
For like features, right?
This is the feature space. So the KNN space happens here, not in the images. The images are only for averaging. But the KNN happens here. So again, that's why let's use this example. I have pictures. All the images look like this. Wait a minute. Onyx will be much faster, I promise. This is more like very, very young still. Onyx is very professional. All right, there it is. So if you click generate, so the images actually look like this, not with the bar, but just like this. Okay. So they're like rectangles like this. That's the image. In one file, I have ID 7 and this image. Let's say 100 by 200. That's one file. The other file, if this was ID 7, has 7 and it has these values, the top ones over here. Oops, well, these top ones over here. Do you see that? Those are the conditions. So if you get confused, think about it. These conditions describe that picture. Why? Because it's a furnace, right? So that furnace had so much natural gas, so much iron ore, so much coal, so much humidity, water, chemicals, right? In fact, there's 10 things in there. So they describe this image. Every one of the 667 images I have, which are slightly different, have a vector of 10 of these conditions that describe it. When I do the KNN, I do it in this space. So it's an R10 space. That's where everything happens. When I enter values in the text boxes up here, it's these values at the top, 10 of them. I describe the type of oven or furnace that I want to see with so much iron ore, so much natural gas, so much this chemical and that chemical. Once I have that, I have a vector that kind of looks like this. It goes into the KNN space of R10. And what does it do? It finds, using the Euclidean distance, the closest K examples or samples. Once I have them, I have the IDs of them, 3, 17, 11. And what do? I go to the other file and look up those 3 images. And once I have those 3 images, I average them to generate my new image. That's it. Got it? All right, so that's basically it. So let's go back to the files. So then, right, so this is one of the second file, and then the last one is this one, conditions. So I suggest use that term so that when you guys are helping each other out, You know what you're all talking about. When you say conditions, you mean that. When you say the images, you mean the other thing. So now go in here, conditions, you see, there's another file with an ID 4 and an image in there that's flattened or spaghettified, right? And then this file has the corresponding ID with the conditions. Yeah.
And the conditions.
Sorry?
The conditions would make up the feature.
This is the feature vector in the space where you're gonna use KNN.
Can you click raw really quick?
Can I what?
Can you click raw really quick?
Can I click raw?
The raw.
It's a CSV.
Right.
That's it. Now, things that you need to do. I mean, we're literally done. So we actually ended. Oh no, we have the Jupyter Notebook, right? We have the Jupyter Notebook. So good. So things you need to do. Decide what problem you want to tackle. Shoes. Okay. So shoes is going to be all kinds of shoes. Shoes that are dress shoes, men's shoes, women's shoes, sports shoes, boots, whatever it is. I don't know. Right? You need to find, let's say, 100 images of that or more. They need to be the same size. That definitely needs to happen. So let's say 100 by 100. They're all the same size. 100 images, 100 by 100. Spaghetti. Let's say you're, to keep it simple, black and white, spaghettify it. Right? And now you have 100 rows because you have 100 images with IDs 1 to 100 and the corresponding image vector flattened, which 100 times 100 is what? 10,000 or something? Yeah. All right. So that's your averaging space, not your KNN space. But then that's easy in theory. Maybe the hardest part of this project is you need to now create a second file, which will have how many rows? 100, because there's 100 IDs. And you need to create, let's start with like a vector of 10, right? Conditions for those shoes. So you could say like sportiness 1 if it's a tennis shoe, right? And then if it's a dress shoe, it's like, that's going to be a 0, but for dressiness, it's going to be 1. And you have to think of how you're going to do that. And like Henry said, actually, his idea was not terrible. Use ChatGPT or whatever it is to label some images. Or a lot of the time, what happens is people post images on Facebook and then they put words on them, which become like the tags of it, like the hashtag. So the hashtags could really be conditions, you know. You got to use your own. This part I can't. I mean, I want you to use your imagination and figure it out. But if you don't want to do that, I mean, you could literally just sit there and just like, you know, create 4 conditions and just enter it for 100 images. And yeah, probably Henry will do that. Yeah, but that's, I mean, in its simplest form, right? You could do that. We did this example already. Refer back to the one of cars. We did electric cars, muscle cars, and something else. And we did this exercise. Got it? Yeah, please, sir.
Features have to be there, right?
Yes, it definitely cannot be words. If you're going to say like big, small, change it to a number, like quantify it. Yeah, 1, 0, yes, exactly. Or more. And test this quickly because it may happen that the results are not great. So then you need to go kind of, all right, what do I need to do to make this better? You see that? To try different things. All right, got it, guys? Any questions so far? The last part of this is the Jupyter Notebook. So let's jump there. That's also in the link. If you notice, we've covered the 3 files. We've covered the index file. Now we're going to call this IPYNB, which is a Jupyter Notebook. Okay. And you can use this one as well to complete the last part of this. Give it a minute. Yeah, so actually this discussion ends today, so I'll probably have something new on Thursday. We're going to move on to our next topic. I really thought it was going to take me 2 lectures, but if I'm not hearing any questions, we're going to just move on. All right, so this is just a regular Jupyter Notebook. It's got I have Torch in here. I mean, you'll start seeing this very soon, very quickly. This is gonna be, we're starting our new neural networks track. And so we're gonna be using PyTorch basically. So it's much more robust. Of course. Matplotlib and pandas. Pill is something that's probably gonna become your friend if you ever do any work with images in Python. It's the Python image processing library, basically. So this is what allows you to bring in images and play with it, okay? Glob, as you probably remember from 372, is just dealing with file system and things like that. And train test split, I may have used this to split the data. So you define a path. So in this case, I have a path on my computer called data images.new civis, right? And in that folder, I just threw some pictures, okay? Now, you want to be efficient here. So I think what they did actually is they had the image, and in the name of the file, they put the conditions. You see what I'm saying? So if you have that, whenever you're retrieving an image, you have the file name and you have the condition values. So that's a clever way of getting the data efficient. But basically the code, we can describe it here. So civis path becomes path, then you do glob, and you select all the images that have an extension .jpg. So literally imagine you have a folder here of images that are .jpeg. Like in your computers, you probably have a whole bunch of pictures of your friends and things like that. That's kind of, so grabbing all the image file names, right? So that I wrote that. I like to look at dimensions and stuff. So I printed the number of images that I have in there. And then I had, this just gives you the paths, by the way. So then so this is just for me, for randomizing things, for generating these images here, and for printing. So I have 5,000. There were 5,000 images. That's interesting.
It's like you got 16.
Hmm?
It's like you have 16.
16 more. I have to print this out, but anyway, this is just for looking at the images here. So this code here just creates a figure to kind of view your images. If you guys just run this code as is, you'll be able to generate something like this, which will have all your, it's a kind of a snapshot of randomly in your folder, right? You have like a whole bunch of images and you randomly pick a few and you show them. That's kind of what it is. So you can use it for your report. So if you guys are curious, this is what the images look like in that furnace thing, the original images. They're black and white. Give me a sec. You can see some were darker, some had like darker here, some had this lighter. That's the difference. But they're very similar. And this is why I suggest that you do like shoes, right? So if you go to like a store, right? We always get like a picture of the shoe in a specific shape. It's like very consistent. So that will probably give you in the end better results, but I don't know. Henry, do you have a question?
With the extra 16, 5K, 16 would be
These are just images from the folder, right? And I randomly picked a few images. I think there are 16 images that got rendered. It's just for viewing it on a random basis. Okay. You don't need this, is what I'm saying, to generate the CSVs. It's just if you want to view your data, you can do this. Might be when you're doing your presentation, you might say, this is a random snapshot of my images. You can see them here. Got it? Yeah. All right. So once you do that, you can see here. This is a function for reading one single image. I do some replace of the path and the extension. And then I take, yeah, I'm just doing several replacements here. Oh, I do a split here on no, the, what do you call this? The underscore. With underscore, I split on underscores to get the values. And then if you notice, this gives me 10 values, okay? These are the values that, because remember, we're going to create two files, one of ID and image and one of ID and the conditions, right? So this is the conditions, the 10 conditions for each image. Do you guys see that? You have to figure out how you create this. This is just specific to how I had it. I had images where the file name had the conditions in it. So 50 natural gas, 6,000 iron ore, 4,000 this chemical or that chemical, okay? These values actually that I see, so they were CO2, NG, oh, here actually. CO2 I had 2, NG I had 50, PCI I had 200, H I had 0, WP I had 0, pH I had 300, OX I had 30, and so on. Do you see that? This is how I receive the files, but it's not how you need to create, okay? So anyway, this function just takes one single file name and returns the values of it. This is just taking, so now let's look at this code here. For IMG and all paths, so now I have all the paths, right, in a list. I'm going to use the pill object image to open from the folder, grab that image, and it goes into my IMG. Do you guys see that? This is the process, right? You have a list of all the images in your folder from Glob. Now you're going to iterate through that list. Once again, you're going to retrieve each image from the folder and you're going to open it as an image. So you're opening it as an image with this object called image. Remember, this is coming from here, from pill image. It's just a built-in library, okay? So now I have an image. For those of you that wanted to know how to well, you guys know how to resize, right? So you can resize the images into however you want with this technique. You can convert the grayscale with that technique. You can convert into a NumPy array with that technique. You can extract the conditions with label function 2, and then basically list of images and list of labels gets the results. Do you guys understand how this works? Yeah, everyone with me? You have 20 images in a folder. Create a list of 20 file names and their paths, right? You iterate through them. Open an image with pill image. You have that image now, okay? And so now you need to convert that image into like a NumPy array, and you add it to a list. And then you also add to that list the conditions which I conveniently had as the file name. Okay, so that's basically the two lists. Then I took list of images and list of labels, and I called them X and Y. I did a train test split, which you can see that there. And this should be what we have here. Yeah, so I'm trying to get to this part. So this part is where we actually save the data. So if you notice, the data gets converted into pandas data frames, and then the pandas data frames are saved via this function to the actual text files. Okay, so this is should be the last part of it. So then between here, the list, between this part here, the X and the Y, and this part, we have to do some additional processing, basically. Okay, so we're going to have to dig a little bit deeper to the details. So let me see here. This is just printing X train. I got the index here. Y train should be the yeah, so I think I have these as a list, if you notice, and I converted these into a NumPy. I created this NumPy array of zeros. So all I'm doing is I'm taking the values in reg vals and assigning it to the NumPy array. It's not like the prettiest code, and there's a little bit sloppy code, but this is the basically what is happening. So I'm taking the values in one list and passing it to a NumPy array. I'm doing that in a loop. Yeah, and then here I just have more lists for the images. This is where I'm actually creating those 3 CSVs. This is just repeating the process, but for X test. So I think I ended up just using X train and I didn't use X test. But it's the same process. Yeah, that's actually not that difficult. Okay, so let's kind of summarize, right? Let's summarize. And as I said, this was very dependent to how I got the data. You guys can do this in a slightly different way, although you will need to read in the images with something like this, okay? So you will need to I don't know what the best way to do this might be. I'm trying to think. I mean, this will vary. What I'm trying to say is that this is going to vary. This is the hard part of this project, okay? I didn't have to label these images. I had an image and it's 10 conditions. So this code just does that. I grab the images from the file, I grab the conditions. It's very straightforward, actually. I take the image, convert it into a NumPy, save the file with an ID, and I take the conditions with the same ID and save it into another file. That's what that code did. What I'm in my brain thinking about right now is that you guys don't have that, right? You don't have images where the file name has the conditions. You actually will have to create this on your own. So your code will need to be a little bit different because of that. So I'm trying to think of how you would go about something like this. Say you downloaded 100 images of cars, right? You need to think about, this is the annotation. How do you like decide what the conditions of this are? Yeah, go ahead.
I've put screenshots so many FTs. Status of.
NFTs?
Yes, that's all.
Okay. Yeah.
There you go.
Yeah, but I mean, you could, I mean, in the end, you could put the conditions in the file name and this code will run as is. The question is, how do you label it correctly? You see what I'm saying? Or not correctly, but just efficient. But you will need to have basically, let me see if I can, oh, let me do this. Let me go here. Let's start thinking about this problem, which is really the important one. All right, so I'm going to do this. Let's see if this is a good idea. I'm going to add a new file, create new file, and I'm just going to call it data example dot cs or txt or something. You see that? So you need to have in your file ID, condition 1, condition 2, condition 3. I'm just going to say 4 conditions. And then what else do you need to have? The image. Do you see that? So I'm going to use this just to kind of indicate the image, but it would be like pixel 1, pixel 2, dot pixel. I'm just going to use 784. Do you see that? That's it. That's your data right there. So now you would have, oops, sorry. So you would have 1, and this you need to define somehow. That's the difficulty of the project. So it's C1. Oops, 3, 4. And then this is just the images, which need to be P1, P2, dot, P784. Do you see that? That essentially is your file. Let's say you do this for 100 images. Dot, 100. Again, conditions. And then image. 2. P784. That's it. You need to get to this point, right? The code that I just showed you can take an image, convert it into a NumPy array, spaghettify it, whatever, and then you have the image. You will have IDs that, they're unique images. But this is the tricky part. This is the conditions part that needs to be, because this is actually what you're going to add some values in text boxes or use the scroll bars to adjust. Do you guys see that? That's it. So maybe what I suggest is just start with like 100 images, start with like 3 or 4 values. It might take you a couple of hours of annotation. And that should be enough, I think, to be able to render some results. But you have to think about the images you want to select. So maybe shoes, hats, cars, things that have similar shapes so that when you take an average of them, it kind of still comes out the same way. Does that make sense? But that's it. This is the whole trick. If you can do it, and there's only the way that the other code works, just remember there's 2 files. So basically it would be like one file has one, like this. So this file would be 100. See that? So basically imagine this is from here is one file and this part is another file. So the IDs match the conditions to the actual image. That's it. Okay. So probably I would recommend that you start with 100 images that are the same size, a conditions vector of size 4, and just label it manually. Label it manually, and then implement that in your code, and it'll give you some results. From there, you can improve it if you want. But that's basically it. So this will be the hardest part. We can come back to this code, the Jupyter code, but work through it. It's actually not that difficult, as I said. But the only thing is that this was assuming that the conditions were in the file name. So that's the end. All right, so it's 7:44. I'll stay for a few minutes. If you have any questions, think about this and see if you have any questions on Thursday. But we've pretty much covered everything except creating the data. All right. See you guys.